Hello creators and creative friends, welcome back to the channel. Today we are going to talk about a very common task in AI image editing, face swap. A while ago, I shared a head swap workflow based on the Flux.2 Klein model. However, face swapping works a bit differently from head swapping. They cannot be combined in a single workflow. Because of that, I decided to make a dedicated video just for this topic. So first, let's take a look at some results. You might notice that the buttons at the top look a bit different from what you see in a local config setup. That is because I'm using Running Hub to build and run this workflow. If you are curious about it, you can find more information through the link in the video description. Now, here is the original portrait. This is actually a challenging case. As you can see, a fork with a cherry tomato is blocking part of her face. So this is not an easy face swap. Now let's check the result. As you can see, a new face blends very naturally into the image. At the same time, the fork and the cherry tomato stay exactly where they were. Nothing strange there. Next, let's look at the reference face. You can see that the generated face looks very similar to the one I provided. So overall, the consistency is quite good. And now let's move on to a few more examples. Alright, after seeing these results, if you are still interested, let me walk you through how this workflow works. Here we have the original portrait. The goal is to replace her face, but there is a problem. The image is very large, 3072 by 4096 pixels. If we try to process the whole image at once, it will consume a lot of VRAM and take a very long time. So instead, we crop the image. But we need to make sure the face is included in the cropped area. So how do we do that? The solution is to use the human segmentation node. This node generates a face mask. It has a lot of options, but I only selected the face for this task. Then the mask box node converts that face mask into a rectangle. After that, the mask box extend node lets us expand that rectangle. You can preview the results using the image and mask preview node. At this point, the area is still too small. We also want to include the shoulders. This helps the model understand the correct angle for the new face. In addition, the cropped area should be a square. This is important for keeping consistency during the editing process. That is why we use the in-paint crop node here. This node prepares the image for in-painting, along with the corresponding mask. The current size is set to 2048 by 2048, but you can adjust it using this node if needed. You can also control how much surrounding area is included by changing the context from mask extend factor. Now let's talk about the reference face image. Sometimes the color of the new face does not match the body or the environment. To fix that, you can adjust the reference image in advance using the color adjust node. For example, here I increased the temperature to make the skin tone warmer. I also lowered the brightness slightly to make the face a bit darker. Of course, if you do not need this step, you can simply bypass this node. Again, we use human segmentation to isolate the face from the reference image. You can see the result in the preview. Sometimes hair can interfere with the final result, especially the hair color. In that case, you can shrink the mask slightly by adjusting the expand value in the grow mask node. Now that all the inputs are ready for Flux.2 Klein, we can move on to the next part. The prompt is very important here. Let me show you a simple and effective way to write it. For example, replace the face in image 1 with the face from image 2. Adjust the new face's lighting, angle, scale, and hairline so it blends naturally with image 1. This is the face generated by Flux.2 Klein. I placed it next to the cropped reference face so it's easier to compare and check consistency. Finally, I used the in-paint stage node to place the new face back into the original image. There is also a backup option in this workflow. In some cases, the face similarity might not be strong enough. If that happens, you can try a different approach. Let's go back to the previous section. You will see a note called Blurred Mask Area. By default, it is turned off. Now let's enable it and run the workflow again to see what changes. This time, the face consistency is still good. However, part of the fork is now missing. So let's take a closer look at why that happened. If you check the earlier step, you will see that the face area along with part of the fork was blurred. Because of the blur, those details no longer influence the final results. This can sometimes improve face consistency, but there is also a downside. If something is blocking the face, like the fork in this example, it may get overridden by the new face. So in most cases, you should keep the blurred mask area node disabled. Only turn it on if you really need better face consistency and are okay with those side effects. Alright, that is everything I wanted to share today. If you would like to support the channel or download this workflow, you can find the link in the video description. Thanks for watching, and I will see you in the next video.